I threw together a quick agenda here on the left. Let me resume my share here. So we'll be doing a quick 10-minute reInvent recap. This is from was it last week, 2 weeks ago? The Amazon reInvent conference in Las Vegas. Pretty good time. I think about a third of the new launches were around ML and AI, so that's good to see. That's what Ansha and I specialize in. So today it'll be me and my friend Ansha Barth speaking. I'm in San Francisco. I'm actually at the San Francisco loft today doing a full day recap if anyone's in the area and you're off work today and you want to come to San Francisco. It's open to the public, just swing by 525 Market Street. We'll be doing a full day deep dive. And right now I'm just gonna give you guys a quick 30 minutes. Actually, it looks like 20 minutes. I allocated to myself, and I'm gonna let Ansha finish it off. I have to run down and start the full day recap about halfway through. So yeah, today, for the first 10 minutes, I'm just gonna recap all of the ML AI services. Ansha is, and then there's also something for Kubeflow that was released during that time, which is called the SageMaker operator for Kubernetes. So this is a way to actually launch SageMaker jobs from your Kubernetes Kubeflow pipelines. Kind of cool. You can get the benefits of a Kubeflow pipeline plus the benefits of the Amazon SageMaker managed service for training. After that, the last about 30, maybe 40 minutes is going to be Ansha doing a deep dive demo into a new product that was released called SageMaker Studio. SageMaker Studio actually builds upon Jupyter Lab. So some of you familiar with Jupyter Lab, or if you've attended any workshops of mine the last year or two, you will have used Jupyter Lab directly. So it's kind of cool. It's a bunch of plugins, and these plugins work with the larger SageMaker ecosystem, including model debugging and model monitoring and model deployments and all kinds of good stuff. So Ansha's going to do that. Last 10 minutes, 5-10 minutes will be Q&A. Like I said, I'll be gone. And I'm going to hand everything over to Ansha so I can go downstairs and start the other full day thing. So let's get right into it here. And I'll do just a quick recap here. I'm going to skip over the SageMaker Studio stuff because Ansha's going to do a pretty exhaustive talk on that, including a fun demo. We have sample notebooks that we'll be sharing with you guys as well too. Also keep an eye in the chat. Down here, we'll be posting links to some of these things that we're talking about, so you can look at these beyond this hour. This session will be recorded. Let me make sure I put that in the notes here. Typical housekeeping stuff. This session will be recorded. Where'd my chat want to go here? Session will be recorded and posted to pipeline.ai. Slides will be posted to slideshare.pipeline.ai. And we will post links in this chat as we get to certain topics for you to dive deeper on your own. Okay, so let me paste in the agenda here. Today's agenda. Okay, so I'm going to do a quick recap right now. So let me jump into this here. Hopefully I can go into full screen share mode here. Okay, and if you can't hear, or if something's going on with the audio, or you can't see my screen or something like that, post it into the chat and Ansha and I will help you out. Okay, so there is a really cool link that I actually pulled quite a lot of material. Yeah, Yeah, actually, Ansha, do you have the link to that what's new? Or actually, let me find it here. What's new? Let me send this to you guys. Let me post this in. One sec here. I think this is it. Okay. Where is the chat? Here it is. This is a list of all the new announcements. There's a pretty cool what's new page. I actually didn't even know about this until a couple days ago when I was preparing for today. So pretty cool stuff in there. And I think Ansha is going to also share a couple links for recaps and things like that that we've been seeing internally within Amazon and sharing with you guys publicly as well too. So these are the products that show up when on that what's new page. If I go back here and do the drop down for machine learning, you'll see a bunch of products. It's always interesting for me to see which products are considered under which category. I had just realized, I think it was last week, 2 weeks ago, that like Amazon actually distinguishes AI from ML, and AI really is, these higher level services like comprehend and forecast and personalize and poly, and ML seems to be falling under SageMaker. So this is both AI and ML, so it has all of them. But you'll see things like Deep Lens, which is a camera that you can push models to and actually do predictions on the actual device. Yeah, Ansha has more experience with that than I do, actually, so she can maybe answer questions later. Also, Deep Racer, which is that fun little car. And there's a new service that was just released at reInvent, which it doesn't even seem to be listed here, but that's the Amazon Deep Composer. And Deep Composer is a keyboard. I actually gave mine to Ansha because I couldn't fit it in my bag. So and I think she actually just got it today from reInvent when it was shipped. So feel free to ask her questions about those. I'm more going to focus on just kind of higher level, what was announced. So there's something called pre-invent, which has become kind of a first-class term here. And these are actually the 2 weeks leading up to reInvent. So reInvent was the first week of December in Las Vegas. I think there were about 3,000 sessions, 65,000 attendees across 5 or 6 of the largest hotels out there. And so pre-invent, just to kind of give you guys context, are things that might not take front and center stage at the actual reInvent conference, but in the 2 weeks leading up, this is the period in time called pre-invent. So we actually, I think there's one, or no, yeah, so it looks like it's just one page here, but these are some of the highlights. So these higher level languages that fall under the Amazon AI stack is there's comprehend, which is the ability to it's like natural language understanding, right? Natural language processing, natural language like understanding. And what we're seeing with these higher level services is more and more like languages being supported natively. There's also higher level services being built on, or more vertical services being built in these like AI services. So there's something called comprehend medical. I believe there's also transcribe medical, and there's lots of new like languages and vertical like uses that are being added year after year and month after month. So keep an eye on that. Also, there's this service called QuickSight, which is kind of like Tableau. I didn't really even know too much about this until the most recent reInvent. And there's ways now you could actually invoke SageMaker models from within QuickSight. So, for example, if you're doing, if you have sort of UI, or not UI, more like BI type of use cases, you could actually do visualizations with QuickSight and at the same time be calling SageMaker models, which is pretty cool. There's also been some improvements to the way SageMaker deploys models. One of the biggest complaints from customers is you could only like deploy a single model to one single endpoint, and now you can actually deploy multiple models to a single endpoint, which is pretty nice, better use of resources, that kind of thing. So again, we're starting to see more stuff in the healthcare space, transcribe medical. I'm going to skim through these. These are, more kind of marketing type stuff. But let's see. Also, so with these higher level services, there's the ability to, I'm going the wrong way here, so there's a service called recognition, which is for like image classification. And straight out of the box, the recognition supports a fixed number of labels. So it can do organs and pineapples and trees and things like that. But really what we want is the ability to customize and to take that same higher level AI service and apply it to our custom domain. So if we're a like car manufacturer or parts supplier, we have torque converters, we have turbochargers, alternators, spark plugs. These are things that did not come out of the box initially with recognition, just based on the way the model was trained. But we can actually fine tune and still reuse these higher level AI services. This is very powerful. This was one of the complaints early on, is that if we were trying to do something custom, we could not customize these services. And so like now we can. And so this is another trend that we'll be seeing with these higher level services, is the ability to customize what they're actually predicting. And this fine tuning process is actually quite simple. You really don't need that many images to train this model. This model, what we're doing is we're transferring that knowledge that this model has gained from its training over those first 1,000 classes, for example, and now just fine tuning it with just a couple hundred images, maybe a couple thousand images from your particular catalog, and the model can now start to predict. So yeah, pretty cool feature. There's a little bit more on custom labels. Some people provide a small number of training images, label them, and the fine-tuned model will be created behind the scenes specific to your domain. There is nobody else that will see this, that like newly revised model. This is 100% owned by you. It gets saved in S3, something specific, and can be locked down to your own stuff. You could also, of course, train video with recognition. You can identify things like these people are playing soccer. You could also start to capture the paths of these people, where they're heading, and start making predictions on that, which is kind of cool. Also, I just found this out last week as well too, that we can actually extract text, and the text doesn't have to be perfectly like horizontal. So we could actually write, detect text that's twisted, turned, and on these skewed horizontal axis. So things that maybe we probably thought were already there, and now are certainly there. The other big one's human in the loop. Customers forced to choose. Do we want human only workflows? Do we want a mix of human and the algorithmic workflows? So here we now have better choices in this area. And at the end of the day, we really want machine learning and humans to work together. There's already a service called Ground Truth that will let you label and crop images and bring a human workforce into the data labeling. But now we actually have more formal. So this new service called Amazon Augmented AI, A2I, is more human review and really meant for humans plus the machines to be working together. Here's a quick blurb on how it works. So really it's tooling, it's integration with the Amazon security model, things like IAM roles, and then of course storing all the results in S3 and being able to share those, visualize those, do what you have to do, train off of those. Okay, so a couple different options. You could either use Mechanical Turk, you can have just a private set of maybe internal domain experts, and then you could also work with third-party vendors. Fraud detection. So fraud detection is obviously one of the more useful uses for machine learning, especially real-time fraud detection. There's lots of bad actors out there. And as the rules are changing, we want humans to kind of help out a little bit here as well too. And so it's no surprise that fraud detection became a like high-level service that's now being offered by Amazon. So top data scientists, hard to find, all the usual stuff here. Finding needle in haystack. So there's this new service called Amazon Fraud Detector. Fraud detection service can be done real time and at scale. These are the key features. You have access to these fraud detection templates. You can use templates to then sort of customize what you're looking to detect and how sensitive you want to be, what kind of trade-offs you want to make if you're trying to optimize for recall, for precision. And models can learn from past, and so these models have actually been trained on many years of people trying to defraud Amazon.com. So that's pretty useful. These are not just, kind of clean room models. These are actually models that have been used to like prevent fraud with Amazon.com. There's SageMaker integration, which is nice. SageMaker is kind of the, think of it more like a lower level machine learning service, whereas AI is these higher level services like fraud detector. But it's cool that you could actually mix and match with your lower level SageMaker integrations. And has a nice tool. I don't think we have a demo of this. Let's see, but here's how you would train it and then ultimately deploy it through SageMaker. Okay, and then there's some more higher level services here. So contact center, support centers, based on customer feedback, this is an area that people were asking quite a bit about. So while each customer could build on top of the speech and comprehend and poly services, these like higher level services, there was this need to actually build more of a vertical. So just like there's comprehend medical, there's now something called a service called contact center that really is a collection of the sort of lower level AI services. And this is used for call routing and better the customer interactions with end users. Supports live calls. You can do contact search. It will do automatic call transcription. So there's a product called Amazon Connect that is meant for these sort of customer service type interactions. And there's now a piece of that product called Contact Lens. And Contact Lens does all of this. So it can do automatic content categorization, can do sentiment analysis in real time, and can sort of light up where the hot spots are. Based on previous issues, this service Contact Lens can actually detect themes and can help prevent things from happening in the future. So here's a quick UI view of this. We see talk time, non-talk time. We see sentiment for these interactions. We see different categories that they have mentioned competitors. They are having trouble hearing, something like that. So that's the actual transcript. This is another service. So the service is called Code Guru. And the idea here, backing up, is we want to improve code quality. So this is a case where we are starting to scale up our team. We've got lots of developers, either onshore, offshore, or both shores. And code quality, we want to actually maintain code quality. So there's been, so this product is called Cloud Guru. Cloud Guru has been, Code Guru. Code Guru has been trained on, I believe it's 15,000 of the top most popular open source projects. And the idea here is to do both static analysis as well as dynamic profiling of your application. So not just the source code, but also it's like memory usage, CPU usage, and we could start to actually tell you and like give you hints as to things you could do to improve security, to like reduce CPU usage, to improve concurrency, all the common mistakes that like developers make as they're trying to hit their like 2-week iteration cycles, sprint cycles. And so this is called the like Code Guru, and there's 2 parts to it. So there's the reviewer. This is really the more static analysis. And Code Guru will actually create pull requests and submit them directly to like GitHub, GitLab, and then it's the like humans' job to then finish off the like pull request, close it out, or just ditch it if it's not valid. And then there's Code Guru Profiler. This is the actual dynamic analysis at runtime. So yeah, here's an example: looping versus waiting. Oh, and one limitation about this product so far is it, for right now, just supports Java and the JVM. That's obviously more like languages are going to be coming soon. So yeah, here's an example where that's the code up there, and then there's this recommendation saying you could use something called waiters, and check it out. Here's a link to how to do this. And so more on how this works: customer's application runs in production, live application, stack traces are being generated, flame graphs being generated, profiler continuously capturing stack information. Also, it's going to detect patterns, things that it has been trained on the open source projects to keep an eye on, and then customers see the actual recommendations. So here's a sample. I think this is a heat map down here, or sort of like a flame graph kind of thing. Oh, actually, this is just so that, yeah, I think that's just blocking out the code. That's not really interesting, but here it's saying strings. There's better ways to do the actual regex. There's kind of inefficient ways and then the efficient ways. So pretty obvious. And then they give you an example fix down here, how to fix this. So yeah, here's the actual flame graph here. So this is where time is being spent. So this is a really fast way for you to kind of look and scan and see what are the hotspots in my system. Yeah. So again, right now, just Java support, and then others coming soon. I don't have a timeline on Python or the other, or C, but Java is out right now. There's this other feature that kind of falls under ML. This is enterprise search. And so this project is called Kendra. Funny enough, this was actually the internal code name used within Amazon. They like typically change the name after it's been released, or right before it's going to be released. They decided to keep it. People seem to really like it. I believe, for example, SageMaker's code name was Iron Man, and then changed right at launch. And back in the early days of SageMaker, when it was first released, you could actually inspect the HTML on the Amazon page for SageMaker and still see references to ironman.jpg and PNG. So Kendra is about natural language understanding, natural language processing, and essentially think of it like an enterprise search. And there's tons of connectors for this thing. So yeah, obviously you can search across things like S3, SharePoint, Google Drive, Salesforce, and then lots more coming soon: Dropbox, Box, Microsoft Exchange. So think of it like one common sort of enterprise search tool. So just like any search, you would first create the index, then add data sources, test it, deploy it. One question that I got asked recently was, does this support more than just natural language? At this time, it appears it does not support image search or anything beyond natural language search, but it's pretty slick. I've seen some samples of it, some demos of it, and it seems to work pretty well. Okay, let's see, look at how much time here. It's almost 9:30, so I'm gonna have to get going here soon. Using Kubernetes for ML is hard. Okay, so this is leading up to the SageMaker operator for Kubernetes. And this is the case, and I think I actually have a demo. Let me pull it out of, this mode here, PowerPoint mode. Okay, so here I have a cluster, Kubernetes cluster running on, this is actually Kubeflow, running on EKS. So here we see my ML pipelines, we see Kati, if you're familiar with Kubeflow, all of these things powering the latest, this is 0.7 release of Kubeflow. One thing, so in the link to this, I'll put this here. Here is the link to the SageMaker operator for Kubernetes. Now, this concept of an operator is something, it's actually a bit of an older term. The kind of newer term is this custom resource. So like custom resources within like Kubernetes are really how Kubernetes is meant to be extended. And so the use case here is I have models that are being trained or deployed in SageMaker, and but I want it to actually get to them from my Kubernetes cluster, for example, running kubeflow. So we can actually do kubectl get crd pipe grep SageMaker. So I followed these instructions. There's a GitHub, there's a nice README. Most of the README works. There's a couple small places that if you're a savvy debugger, you could figure out what's wrong. Hopefully they fixed it. Maybe it was broken about 2 weeks ago. But and so I've installed this custom resource definition. And if you're not familiar with this term, you might be familiar with like user-defined type or user-defined function. You know, in sort of the like database land or in like developer languages where you can add your own types or classes. Or so the like SageMaker folks have created this open source operator or custom resource definition for Kubernetes, and I can now access. And so this is actually called training jobs. So I could say get training jobs for short. And I had previously submitted one, looks like earlier this month, submitted one, looks like it failed, but it was actually Bruce Demnist. And so there's ways to actually, let's see if I can find the, I can't remember if it's, and so all of this is open source. Let me send you guys the link to this. For the workshop. This is not complete, so just know that there's probably a bunch of stuff that's not totally working, but you can kind of see this is an in-progress repo right now. Let me check notebooks, part 3, SageMaker operator. Yeah, so this, once you get this, no, I think it's actually via XGBoost. So this is a training job, and I can use this kind now. So like Kubernetes now knows something called training job, and I can give it hyperparameters. I can give it some more details, like here's the Docker image for this algorithm. Here's the regions in, here's the S3 buckets that it's going to be, that we're using. It's telling SageMaker which instance type to use, giving it some timeouts. I'm basically telling it where is the input data, where should you put the output, and giving it some sort of arbitrary keys that you can label on the SageMaker side. Okay, so once, if I do this here, boost, let's see, when creating, okay, so I'm not quite sure what's going on there, but just know that that's now available. You can like retrieve jobs. You can get the status of these training jobs, and really kind of bridges the best of both worlds, right? So you could still continue to use kubeflow pipelines. And let me give you the link to this real quick. It's going to be community.pipeline.ai. So this is the actual community edition right there. And let me get back to the PowerPoint here just to finish this off, and then I think I'm going to hand it over. So yeah, Ansha is going to talk about the SageMaker Studio stuff based on Jupyter Lab, as you can see. Also talk about SageMaker jobs and the ability to compare experiments. I'm not going to steal her thunder here, but there is another section down here. So here's a section on AI-based gadgets. So this is where Deep Racer comes into play. This is where Deep Lens, the camera. Yeah, Ansha knows a little bit about Deep Racer too, so you could ask her. Here's that thing called Deep Composer. Still not exactly sure what it does, but everyone on my team went crazy for it. You can use a pre-trained model or train your own model. You can essentially compose music. So I believe all three of these are for sale if you want to spend a bunch of extra money for friends and family during Christmas. There's two new frameworks that have been created. One's called Deep Graph, and this is available for use within SageMaker. And this is essentially graph-based like neural networks, so used for common things like recommendation, social networks, cybersecurity, and then also Deep Java Library. I have not yet used this, and I don't know how it's different from deep learning for J. But yeah, keep an eye on that. Also, I discovered over the last couple of weeks this thing called the AWS ML Embark program, and really it is partnering up with the ML Solutions group within Amazon. And you can actually get sort of one-on-one, more kind of closed form training here. You could do a workshop to help identify POC use cases, and then working with the ML Solutions Lab, which I believe is based here in, I think it's Palo Alto. And essentially you're brainstorming, modeling, operationalizing, and then transferring the knowledge. So these are some of the folks like Major League Baseball, NFL, Cerner that have taken advantage of this service. Okay, so I think with that, Ansha has the exact same slides that I just skipped over. We were syncing right before. And Ansha, I'm gonna pass it over to you and then probably hang up here. So
yes, perfect. If you just stop sharing so I can steal.
Cool. And then this is recording also. So when I do hand it over, can you make sure that the recording stays?
Sure. All right, guys, let me quickly share my screen here. I'm gonna share the desktop. Okay. So you should see my slides coming up here, I hope.
Yeah, looks good.
Perfect. All right. So yeah, thanks, Chris. Quick introduction. My name is Antje Bart. I work as a developer advocate for AI and machine learning at AWS. And I want to use the rest of this call to walk you through the SageMaker launches specifically. And I'm also going to show you in a demo. So I'm going to keep the slides here short so we can actually also see what's happening there. So just as a quick introduction here, a little bit of the motivation. So I guess most of us know working with machine learning, it's a very iterative process. There's tons of tools, hundreds of iterations to do. And it's really kind of difficult to bring all of that together, let's say, in an easy environment. And that was basically the motivation for AWS to launch Amazon SageMaker Studio, which is, for those of you who have worked with SageMaker before, maybe a new kind of integrated developer environment, which we will see in a bit, that helps us to collaborate at scale. So we do have something called SageMaker notebooks now, which are basically very easy notebooks you can just start working on. You can share them. We can also do something fun now with experiment tracking. We do have a new added capability of AutoML, which is called Autopilot, which I'm going to show, and a lot of other stuff. So basically, hyperparameter optimization has been part of SageMaker already, but now with the Autopilot, we can even bring this a level further and also help you just based on basically a raw input data set to suggest through this Autopilot the actual problem we're trying to solve based on the data, and then come up with candidates, selecting the right algorithm and framework to work on the problem, and then also like running through training and tuning jobs and present you in a white box model exactly what steps have been performed and can help you as a data scientist actually in your daily work to kind of offload this work a little bit. So as Chris already mentioned earlier, SageMaker Studio is based on Jupyter Lab. So for anyone who has been working with Jupyter Lab, the environment should look familiar to you. We have added a couple of extensions, obviously, but the general look and feel will be pretty much similar to Jupyter Lab. So the next thing we've been working on, as I quickly said, was to make it easier for data scientists to collaborate across teams, share notebooks, etc. And this is basically the reason we've come up with Amazon SageMaker notebooks, which are really, as I said, easy and fast start shareable notebooks. So you don't have to provision a Jupyter instance anymore to host them. You can basically just start by creating a notebook, and then later on you will also have the flexibility to actually upscale and downscale the compute resources. This is not yet implemented, but it will come. And I think I have a screenshot here. Yep. So once you have a notebook running, you can basically later decide if you need to scale it a little bit up in terms of compute instances where it's running on, or scale it down, etc. Right now, it's coming automatically pre-provisioned. So you don't have to care right now which environment you need to start it on. And then for the sharing part, which is pretty neat, which will also come shortly, is you can create a shareable snapshot of your notebook. You can decide, if you can see it here, to whether include the Git repo information, to include the notebook output or not, and then create the snapshot, and you can share it with any one of your team members, for example. And as it's a snapshot, you can keep working on your version, and it will not affect the snapshot then that your teammate might be starting to work on. So pretty neat in terms of helping you to collaborate among teams across departments in your organization, etc. The other question was around how can we make it easier for you to do data processing and model evaluation, right? It's a lot of manual work. Again, a lot of tools and services included. And we came up with Amazon SageMaker processing. So you can now define jobs for data processing and model evaluation within SageMaker. So there's a couple of different options here. You can bring your own script for feature engineering, or you can use a couple of built-in mechanisms from SageMaker, built-in containers, etc. And also we will see when I run the autopilot demo in just a bit, how that is also part of autopilot to do actually the data analysis and then also feature engineering and data pre-processing before running the training and tuning jobs all automatically. And then, yeah, resources are created, configured, and terminated automatically. So that's kind of the nice thing with all those new services, that it's basically, you don't have to care about the infrastructure provisioning part, right? So SageMaker is helping you and abstracting that and doing the job for you here. Okay, so the next big thing, and I think that might be really, really of interest for a lot of you, is how can we make it easier to do experiment tracking? So we introduced Amazon SageMaker experiments, and now we can run experiments at scale, and we keep track of all the different trial runs, and you can visualize those. You can work with those through the SDK. You can work with it through the user interface, through the SageMaker Studio, and it really helps you to keep track of all the experiments, the trials, compare them, and it's really, really nice and easy to get started here. So this is how it can look. I'll go quickly through this here because I think it's much more interesting to see it live in the demo here. And then another big thing is around debugging, right? So when you're training your models, in many cases, it's really hard to understand what's happening, right? Especially if you look at deep learning, you're using large neural networks with many layers, many connections. It's kind of a black box what's happening throughout the training. And we introduced Amazon SageMaker Debugger, which makes it easier for you to keep track. So Debugger is using something called rules, where you define kind of metrics you want to look for. So for example, you want to look for if the training, the validation loss is not decreasing, or if you're actually starting to overfit during the training process. Those are a couple of built-in rules. You can also build your own rules. And then basically throughout training, we will store all of the tensor information, what's happening throughout the training. and we will keep track of the rules you're attaching and give you an alert when something is triggered. So it's pretty nice, as I said, good visibility into the training jobs, and makes it easier really to help with the explainability and yeah, the whole debugging and understanding what's happening throughout the training runs. Again, this is how it could look like in Studio. I'll show you in a bit. And then finally, it's about deploying a model, right? You want to continuously monitor it in production to kind of be able to identify if there's a model drift happening, etc. So the other thing we launched is SageMaker Model Monitor, which will help you to continuously monitor the model once you pushed it into production. And what you can do is basically you can create a baseline of how yeah, the behavior should look like. And when the model is actually drifting from your baseline, you can have the analysis, you can collect the information, you can see it in CloudWatch. So you can set CloudWatch alerts on specific things that are happening. And again, I think this is a really, really big step forward in terms of helping you to come to this production machine learning pipeline environment with all of the different launches that had happened here, from experiment tracking to debugging training runs to being now able to monitor the models in production. And again, here, for example, it's a visualization of what's happening of one of the deployed models here. You can define the visualization part, and as I said, it's much more detailed with all of the metrics stored in CloudWatch. But again, easy to get started, and then you can really take it from there and build whatever alerts and visualization you need to do. All right, and the last thing I guess here is, as I said, the autopilot, which we will show here in a bit. Basically, the idea is to implement AutoML, which you just hand over the basic raw data set you have, and then autopilot will have a look at the data, come up with a problem we're trying to solve here. For example, if it's a binary classification, and then pick a couple of algorithms and play around with the hyperparameters and basically deploy a couple of candidates and then tune and find the best model and parameters, and then document it for you to either just keep them and use them, or if you want to tweak and have a look at it, also, like, everything is documented. So again, easy for you to have a look at it and take it from there. And with that, I went quick through the slides. Sorry for that rush, but I think we want to use the remaining time here really to make sure that that we see here what's happening in the demo. All right, so I'll jump here in the SageMaker Studio. So again, you should be familiar with the layout. It's very close to Jupyter Lab. And if you want to get started here and you have an AWS account, just make sure you're navigating to the US East 2, the Ohio region. This is where SageMaker Studio is now in preview. And then navigate to SageMaker as a service, and then you will find the link to start and onboard to Studio. And then once you've done that, you get this customized link here to your environment. And you can create users through SSO, single sign-on, or IAM. And then you can basically hand out the link, and users from your team, from your company, once you onboarded them, can actually use their own single sign-on to get access to the Studio environment. So they don't need to have AWS console access. It's pretty neat. So you have an administrator setting this up, and then you can start working with it through that link and the sign-in. All right, so what we see here, as I said, is close to Jupyter Lab. So you have here kind of the file explorer. I can open a terminal here, and if I do a quick look, the directory we're in. So you see here home SageMaker user, and this is basically a directory that got set up on Amazon Elastic File Storage on EFS. So it's a shared file system, which is mounted to all of the notebooks you're going to launch here. So whatever you're storing in here, you have that volume mounted to the different notebooks, so you can work with the data, etc. From here, you can do the git clone, etc., whatever you want to do, and pull down sample notebooks. So if I go here on the left through the menu items, you see the running terminal sessions. There's the Git integration, a couple of commands listed. We do see here the section for experiments, and I'm going to show you in a bit. So those are the experiments I already ran earlier. And you can, for example, go in here, and then you see the different trial runs that we're running here. So you see a lot of tuning jobs, trial runs that I executed earlier. You can have click on one of those, open in a component list, so you can see the individual parts of this trial run, couple of components in it. And then you see here's a processing job, it's a training job, a transform job. So all the different parts that this was basically an autopilot job is performing as part of the experiment here. And then you can always go into a little bit more details here. So for example, I open that the tuning job here. You see the metrics, parameters set for this run, and also where the artifacts from the training ends up. So everything here is basically stored in a bucket on S3 that you are giving the job in the beginning. All right, this just quickly here for the experiment section. And then here on the left, a couple of notebook or studio tools. You see the endpoints that are currently deployed. So I have 3 endpoints currently provisioned and the open windows. So that's for the navigation part of Jupyter Lab. All right, so let's see what we can do here. So what I've done, I've pulled down a couple of sample notebooks, and I'm going to show you here what we can do. So I pulled down one notebook here to work with sample data sets. So I started with just doing a couple of pip installs. So I pulled in pandas, numpy, the SageMaker SDK, the AWS CLI, Boto, made sure it's the latest version. And then I pulled down a data set here, which is basically, if we have a look at it, let me just make this a little bit bigger here, which is basically a data set of marketing customer information. So you see here age of persons, the job, education, contact. And the idea here is basically to predict through a marketing campaign whether those people are inclined to accept the marketing offer. It's direct marketing campaign. Okay, so basically the problem we're trying to solve here is the last column, which is called why, and has a couple of no's and yes in it. And basically it's the decision whether this particular person actually signed the offer that was made or offered, yeah, through the marketing campaign here, yes and no. So it's a binary classification problem we have, okay? So as a next step, I basically split the data set. So I kept 95% for training data and another 5% for my test data at the end. I uploaded the data set here, the CSV files, to an S3 bucket. And then I can basically start the autopilot job. So there's a couple of different ways you can do that. So you can either do this through the SDK, or what I'm going to show you is you can also use the SageMaker Studio here to kick off that autopilot job. So the only thing I need to do here is basically copy that path where the input data is. And I'm using this train 95% of the data set here. And then basically the autopilot job will split that into the training and the validation. And I keep my testing data to actually test it after that. So I'll copy that location. And then what I can do, I go here to the experiment section on the left. And I create a new experiment. I kind of call it AutoML. I call it demo 2. I had one demo running already. And I'm going to give it here the S3 location of the input data. It's exactly what I just copied here. And then the target attribute, it's the Y column to decide whether or not the person we're calling is willing to accept the marketing offer. And the other thing I'm gonna do is I give it an output location as well, where it will store like the results. So I'm gonna take this path, and then instead of the input, I will give it an output path. Okay, so select the machine learning problem type. So I can either say, okay, this is a binary classification problem, or I can let SageMaker autopilot figure that out. So I leave it here at auto. And do you want to run a complete experiment? Yes, run the whole process, or I can also say just create a notebook with the candidate definitions. And I'll show you that in just a bit, but for now, let's say do the whole AutoML job. And with that, I'll create my experiment. And then what we'll see here in a bit is basically that it takes the input data, which I provided, starts to analyze the data, and then also provides feature engineering and recommendations. And as I selected do the whole job for me, it will start performing the data preprocessing and feature engineering. It will come up with candidate models. It runs the model tuning, and then at some point it will stop. So this whole process can take probably 1 or 2 hours, but I just wanted to kick it off. And then I have one that I already executed earlier where we can see the results. So I'll just have to give it here a little bit of time to actually pick up the job so we can also see something here. So in the meantime, let me go to the job I ran earlier to show you actually what happens here. So if I go to the run that I've done earlier, you will see, and we'll see this in the other one as well in a couple of minutes. It went through the data analysis part, and then once that is done, it generates notebooks for you, and you see the links up here. So I can open the data exploration notebook, and this is the output of the autopilot after looking at the data. So it tells you that it has read close to 40,000 rows from the training data set. It had 21 columns in there, and the column named Y is the target column. So this is actually the piece we provided. But then on its own, it came up with, it's actually a binary classification problem with 2 examples of the labels yes and no, right? So that's all that autopilot already figured out itself. So here we see an example again of the data set. So it has a sample of 10 rows here. And then it does analysis. So for example, it figured out that there's some percentage of missing values in the data set, right? In this case, the data set is pretty nice already. So it's just like one of the columns that contain missing values. Could be a lot messier data sets out there, maybe you are working with, right? In this case, it's just really just one column, but then you see here in those blue boxes that it actually suggests action items for you. So here in this case, it suggests maybe you want to replace all missing values with a new default value, or you can do some feature preprocessing and maybe work with something from scikit-learn, the impute, simple imputer, to actually preprocess and fill missing values. So it's giving you really actionable suggestions here. It also looks at the columns and sees whether it's categorical, whether it's numerical, and always suggests how you can basically optimize the data set for the actual machine learning problem. So I'll go quickly through here. You can have a look at those, and I'll share the sample notebooks with you so you can give it a run yourself. So, and then it calculates a lot of different things here, which probably data scientists would do as well. So for the different columns, some mean, median, min, and max values. And this is kind of really, as I said, the output from the first data exploration. So when it's done that, it basically starts doing feature engineering and is applying all of those suggestions. And then it comes up with another notebook for you, which is the candidate generation notebook. And I quickly open that one here. So here again, it's building on the first insights. It knows it's a binary classification. And what it does now is basically looking at the best algorithms to train the model and kind of come to the best performing model. So it's selecting a couple of parameters. It's selecting hyperparameters, and then it starts off basically the search for good candidates. And you can see here candidate selection. So it's slicing the data, it's deploying a couple of models, and then it's using the built-in hyperparameter optimization functionality to basically find the best set of hyperparameters for those candidates. So you can see here the 10 different definitions. We can tell them how many candidates it should produce. So in this case, we told Autopilot to come up with 10 candidates. And basically you see here all of the definitions, right? So you see here, for example, for candidate number 1, what's the data pre-processing here? The algorithm it chose is XGBoost in this case. It applied a couple of data transformations here, which is all documented. Here's the second candidate, which is using linear learner, which is also able to do binary classification. It's a built-in algorithm in SageMaker. And then it's applying a different set of basically pre-processing and feature engineering tasks here. So basically, if you scroll down, this is the list of candidates. And then at some point, as I said, it kicks off the training jobs, the tuning jobs, and then comes down with the results. And you can pull for the best training job here and then decide whether you want to deploy the best model into production, the best pipeline, and then, yeah, start working from there. Or you can use those notebooks to actually tweak a little bit if you're an expert data scientist and maybe want to add something or do something different. If you don't have that much knowledge, you can basically take the results, and Autopilot already did a lot of good work for you. All right, this was kind of quickly to show the notebooks it generated. As I said, here you see all the trial runs that have run. And basically you can sort here by the objective metric. So this is the validation accuracy here. And you can see here the worst ones were with 11% accuracy. The best model would be here, the top one, if you're sorting that. And you can then go ahead and either deploy the model, or again, you can have a more detailed look at that specific trial run. And you also see the ones I just started that are actually happening right now here from the other job. So it's pretty neat. So what you can also do here is, for example, select a couple of those and then open in the component list. I'll just try to capture some here. Let's take those that are actually finished. And then you can, for example, do add a chart. So maybe I want to compare those 3 training jobs, right? So I selected those and I say, well, maybe give me a summary statistics, or actually a time series. Let's see if that works with a line. I do time. And let's do a 1 minute. Let's see if this makes sense here in this example. And I might want to do validation accuracy. Yeah, that probably doesn't make too much sense. I'll do summary statistics, scatter plot. That probably makes more sense. And I'm gonna plot, let's say, validation accuracy against the training accuracy. That makes more sense. And I color it by the trial component name. So you see here, they're very close together, but I can basically zoom in here. So there's a scatter plot. Choom, choom, choom. And you can see here it plots those 3 very close together, I think 2 points here. But basically this is how you can select trial runs and then do some visualizations here. So you can see 2 of them are pretty close together here. Pretty close and similar on the validation accuracy and training accuracy. And one training job here, or one trial run, was basically higher on the training accuracy, as well as in the validation accuracy. So, and you see the details here again, right? So this is how you can work with those experiments. You can visualize, and basically you have them all kind of documented here in this experiment run, and then you can go in and see the actual trial runs here happening. So pretty neat, and we can see the job I just kicked off, the auto demo 2 here, that are actually the first jobs are running in here as well, as you can see here in progress. All right, so let's switch back here to one of my notebooks actually. So we've seen how that works. So yeah, you see here the demo 2 is done with analyzing, and it's doing the feature engineering currently, and it generated again the 2 notebooks here. So once you have those results, as I said, you can basically use the endpoint that gets deployed. So in the previous run, I deployed the best model that it came up with, and then used the test data set to run predictions against. And basically, I was calculating here the confusion metrics and also accuracy, precision, recall, F1 score. So in this case, this is the confusion metrics here. So we see we could still improve the model a little bit, but hey, for a first run, pretty nice, and came up with 91% accuracy here, and an F1 score from 78%. So this is how you can work here with SageMaker Studio. In the interest of time, we can't go through all of the features here, but there are a lot of good GitHub repos, and I just want to quickly share the links with you. So for example, on GitHub, AWS Labs, Amazon SageMaker examples, you find a lot of sample notebooks here. For example, if you go to Autopilot, there's this direct marketing example, which I was using, which actually runs the code through the SDK instead of the UI. So it's also good how you can trigger those jobs through the SDK programmatically. You see here sample notebooks for the model monitor, which will look at the predictions or like all the metrics once the model is deployed. And actually, I can show you quickly here. It's getting populated then once you set it up to CloudWatch. So here in this case, you can see here, this little dot here was just the invocation I issued to this endpoint that is in production. So you can basically here select whichever metric you want to maybe look for. So I had invocations here. You can do model latency and a lot of like different metrics to monitor here through CloudWatch, set alarms, etc. Also, maybe quickly, let me see. There's also, this is the direct marketing here through the SDK, how you can do that. And if I go back here, I think it was in here, the debugger. So yeah, this is the notebook that shows you how you can use debugger. And I just want to quickly show you this in the last couple of minutes here we have. So what you have to do is just pull in a pip install SageMaker debug library. And then what you're doing, you pull in the normal library, SageMaker, TensorFlow in this case. And with the debugger, you can pull in rules and those specific configs. You can bring your own training script, for example, here, or the entry point script, basically. And then when you set up the training job, the estimator in SageMaker, the only difference here to how you did it before is basically you're passing it a couple of rules. And as I said earlier, there's a couple of pre-built rules that you can just use. For example, here's vanishing gradient, or check for the loss is not decreasing. You can also build your own rules. And then once you build the estimator here, you're basically passing on those rules. And then throughout the training job, when you kick it off here with the fit command, you will see in the output that also there's like, in addition to the actual training job, it will look for those rules. So vanishing gradient or the loss not decreasing. And again, this gets all documented in the CloudWatch environment. So if I go back here, this was one of the earlier runs. You see here vanishing gradients. Step 0 had 0 vanishing gradients. So basically, in this training run, this problem did not occur. And also here is the loss not decreasing. And also here, no tensors matching the regex pattern given were saved. So in this case, the training run didn't like trigger those exceptions. So I think we had a pretty good run. And this is all getting logged here in CloudWatch, as I said earlier. So pretty nice, and you can have really good insights to what is happening. If you want to learn more, you can check out Amazon SageMaker documentation, for example. Let me just pull up that one here for you. So let me see, where's the chat window? So here's the documentation for SageMaker. You can see here what I'm just sharing are the built-in rules for Debugger. So you can see a lot of rules, like for deep learning, you can do dead ReLU, exploding tensor, all 0, which is probably very bad. When does it start to overfit, maybe? For XGBoost, you can check on the tree depth, etc. So a really good amount of rules already built in. And then obviously you can also build your custom rules, and it's all pretty nicely described here. So let me also share with you the Git repos here. So if you want to learn more really and use some sample notebooks, have a look at the GitHub repo. And also I was using a couple of notebooks here, especially the dataset one from our colleague Julian. And he also has shared this notebooks here on GitLab. So feel free to grab those, clone it into your environment, and then you can start experimenting here. And given the time, I think that's a wrap for now. I quickly wanted to show you in this very rough overview here, and sorry that we're a little bit tight here for the demo and the time, but just a quick introduction to this SageMaker Studio environment here, how easy it is really to start notebooks, and the notebooks are really here. If you launch a new activity, you can start a Python 3 notebook. There are a couple of different kernels available. So I guess the easiest one is if you go Python 3, and there's one called for data science, which has already a couple of libraries installed. So it's pretty easy to understand if you've been working with Jupyter and JupyterLab before. So you can basically deploy a new notebook, and this is basically running a completely hosted notebook here for you. You don't have to worry about which infrastructure instance type you're deploying it on. And as I said, pretty soon we will have the functionality in here to actually share the notebooks then, and hopefully make it easier for you to collaborate and build, deploy, train, and optimize your models. I hope you find it interesting. So we walked you through a little bit of the new launches today, of the studio, the debugger shortly, the autopilot functionality, and hopefully you could have some inspiration here. And let me see if I think there haven't really been any questions. If you have any more questions, put it in the chat window. So I'll hang in there for a couple of more minutes. And I think, let me just quickly jump back to my slides here to wrap it up. So we saw the demo of SageMaker Studio. As I said, make sure when you want to try it that you're jumping to the US East 2 region. It's currently in preview in the Ohio region. So this is where you will find the link in the SageMaker service dashboard. And with Studio, we now really have kind of this integrated IDE environment where you can start experimenting. You can use the collaborative notebooks. You can start building and training your models. You can start using the debugger to actually see and record what's happening throughout the training runs. You can then use SageMaker Autopilot to kind of come up with a first suggestion of how to tackle your problem. And as you saw, I only passed the raw data set, and then Autopilot already came up with suggestions how to do the data pre-processing. Feature engineering came up with candidate models. And you can actually pull them also nicely through the SDK, get the list of candidates, and then crack them open, look into them, or deploy the best model. All of the experiments and trial runs get tracked. So you also have them available if you want to look back and then have more explainability, what happened in the runs and trials. And then you can use the deployment and the monitoring. So once the model is in production, you can watch for model drifts, etc. And then really help you in creating this end-to-end and continuous machine learning pipeline here with Amazon SageMaker. So a couple of links I pasted, the SageMaker docs link, I pasted you the 2 GitHub links, and also, if you want to have a look at what else has been launched at reInvent, Chris was making a quick introduction to the other AI services. But you can have a look at this link here. There's a collection of all available recordings from reInvent and also podcasts. So you can maybe tune in a couple of sessions that discuss those launches in a little bit more detail and take it from there. And with that, nothing left to say than enjoy, start building cool stuff, and always happy to hear your feedback. Let us know if you like the new services, if you're missing something. We're always very curious to hear from you, how you like the services, how you're working with them, and obviously always if you're missing something as well, so we can improve the services and make it the right thing and help you to make your job easier. And with that, thank you very much for your time. I think we just went a couple of minutes over, but I hope you could stick around and maybe learn something here. And as I said, I'm going to stick around a little bit more for questions here. But with that, thank you very much and have a great day.